Hi everyone, welcome to this video on the final lesson of the atomic structure and periodic table scheme. This lesson is on alloys. I'll get straight into the explanation here. And it's funny, I looked through an exposition I did quite a few years ago now, maybe 5 years ago. And what I really noticed about that is that what I did there is went straight into the abstract. So I just went straight into drawing these pictures of kind of little positive ions and delocalized electrons going all over the place. And I didn't start with the concrete. And you can probably guess, my students found this pretty difficult. They didn't really know what I was talking about. So what I'm going to do in this video is have a think about how I might start with the concrete and just give them a bit more sense of what I'm talking about when I refer to alloys. So this lesson is about why we use alloys and you know, how mixing metals with other metals, i.e. making alloys, can give them more helpful properties. There's really two main properties that this lesson focuses on. One is using alloys to make metals harder and stronger so they don't bend and they don't snap or whatever. That's one aspect of it. The other is a cost issue, and we'll look at that in the second diagram. But let's think about that first one. How can we use alloys to make metals harder and stronger? So I'm going to ask students to imagine some sort of axe. So I mentioned the Bronze Age. This is when human beings learn to make bronze, which is now I'm going to have to check this. I've forgotten. Bronze is an alloy of, what is it? Copper and tin, I believe. Yeah, copper and tin. So, but let's imagine before the Bronze Age, we had this axe and it was made of copper. So let's put copper axe here like this. And what I'm really talking about is the blade of the axe. And if we zoom in on this, well, what we learned about in the previous lesson, so we're building on that prior knowledge again, what we learned was that the structure of copper is something like this. And I'm not going to go into this in loads of detail again because we already taught this, but we had these 2+ ions, copper 2+ ions. For the rest of them I might just put 2+, 2+, 2+, 2+, as follows. And then we can add our delocalized electrons in here. I might do these in a different color this time, so I might do these in red. So these are my delocalized electrons. And what we want to remind students is that as we saw in the previous lesson, these delocalized electrons, they're free to move, and they also act as a kind of oil between the layers. And what that means is, if you strike, let's say, a tree trunk or whatever it is that you're chopping with your copper axe, if you strike it really, really hard, you can essentially make some of these layers slide over one another. So you can make some of these layers slide over one another or somehow slide out of place. And what you might end up with then is, after you've had a go at chopping down your tree, so here's my tree trunk here like that, your axe might sadly look a little bit misshapen. So if there's my axe, I might draw something like this. My axe has got a bit bent. I've got a bent axe, which is obviously not what I want. So I might just put misshapen or out of shape, something like that. I think misshapen is spelled like that. Anyway, the point is that this is that the reason this has happened is that this is because these layers have been allowed to slide over one another because of the structure of the copper. And again, it's worth emphasizing, I've started with the concrete, I've zoomed in to look at the abstract, and then I've gone back to the concrete to say, if that was true, well, here's what I'd expect to happen. So then let's look at bronze. Let's look at a different axe, this time one that's made of bronze. So this is now a bronze axe. And what we can do is explain to students that Bronze Age people worked out that if you put copper and tin in a fire together, you can make this kind of new material called bronze, which is a mixture of the two. And it's a good opportunity to revisit some of that stuff we did a long time ago, back in year 7, about differences between compounds and mixtures and so on. So what I'm going to do here is draw something like this. Now, this is very much a schematic diagram. This is not an accurate diagram of exactly what bronze looks like. But what I want to do, I'm just going to illustrate this by imagining that actually these atoms, or I suppose they're positive ions of copper and tin, have different sizes. So if these are Cu, I'll do some Cu and so on. So Cu2+, Cu2+. These smaller ones, let's say, are tin. And I've got to say, I have no idea what the charge of a tin ion is. I'm going to guess it's 2+. If I've got that wrong, then I'm sorry. You might need to look that up. But let's add some tin ions in here, like that. Oh, sorry, that's copper there. 2+. So these smaller ones are tin, and these bigger ones are copper. Now, what you want students to notice is that by adding these extra ions into your lattice, well, you've kind of stopped it being a lattice at all. So yes, you've got lots of metal ions in there. You're still going to have your delocalized electrons, so it's still most likely going to be a conductor because it's got some of those delocalized electrons in there, but it's no longer that lovely lattice that we had in the previous example. And again, you can either explain this directly or question students a bit on this to get them thinking. But the point is that when you whack your tree trunk with an axe made of bronze, when these layers try to slide over one another, I mean, you can see it illustrated quite well here. Well, it's not a layer. You can't. They kind of bump into each other a bit more. There isn't this kind of smooth gliding over one another that you get with the pure copper axe. So you don't get the same movement. You might add a bit of movement, but it's a bit of a back and forth movement, something like that. You've got a much more rigid structure at the molecular level. So therefore, after you've been hacking down your tree trunk and you're left with a stump, well, your axe remains in the shape that it was. And this is why, it's not a very good axe there, but hopefully you get the idea. And this is why the Bronze Age was such an age of development for humankind, because they had much better tools as a result. And I might add here, although my diagram does not show this, but anyway, same shape. The point is, it's not been bent because of the structure at the atomic level. The metal didn't bend; it didn't change shape. That's why bronze alloy tools are better than those made of the pure metal. The other example you could give is just to make a contrast between different gold rings. And again, if you happen to have a gold ring, so I've got a gold ring here, my wedding ring, definitely show students and ask them what they know already about gold rings. They've probably heard of this carat system, and what you can illustrate is that, well, these different carats of gold work in the following way. So what you can do is, if I draw a gold ring like this and a gold ring like this, and then show the different carats, if we zoom in here like this, I'm going to just move down here on these two, and I should say, actually, sorry, if this is, let's say, a 10 carat gold and this is 24 carat gold, well, if we zoom in, what we see, firstly, let's do the 24 carat gold. Now, I don't know the origins of this system. I don't know why 24 was considered as the number for pure gold, but anyway, or nearly pure gold. But this is what it looks like on the inside of our 24 carat gold ring. We've got the fixed lattice. Again, you could talk about ions and stuff as well. I don't know the charge of a gold ion off the top of my head. But it's probably worth emphasizing. It's still going to be a metal, so it's got these delocalized electrons and so on. But the main thing that you want to draw students' attention to is that all of these are gold atoms, or well, really they're ions. Yeah. Before you teach this, do what I forgot to do before this video. and check what the charge for gold ion is. But anyway, these are all gold particles, let's say. I'm going to hedge my bets and say particles. Now, what you want to illustrate is that, well, actually gold, that's the most expensive, apart from platinum, but it's one of the most expensive materials on Earth. And there's actually a market for having rings that are kind of shiny, but maybe not quite so expensive. So what you can do is make different carats of gold, and 10 carat, it's 10 over 24, so off the top of my head I don't know what it is, about 40%. Only 40% of the atoms in 10 carat gold are actually gold. And the others, and we can maybe draw them different sizes as well, just to illustrate. We can just do some kind of random ones like this. But the others are not actually gold atoms. So the point is, if I've got a certain number of atoms here, yes, about 40% of them are going to be gold. Like this, but not all of them. So something like that. So all the rest, well, it's made of different metals, so you might have some silver ones here. So let's add a few silvers, Ag. We could add a few, there's a few nickel maybe, even zinc. So there's other elements present. Why don't we stick a bit of copper in as well? Yeah, let's add one more nickel, let's say. And therefore, rather than being pure gold, like 24 karat gold, 10 karat gold is still gold. It's got 40% gold atoms in it, but it's a lot cheaper because a lot of it is those cheaper, more base metals, and that's what makes a 10 karat ring just a bit more affordable. So there's two examples of why we use alloys. And again, the point that I made at the start of this video and that I would stress now is that rather than just shooting straight into the abstract, start with the concrete examples, illustrate the point through here, because once you've looked at these two examples, and you might look at stainless steel as well, I think that's a really good example to use. Once you've looked at a few examples, then you can come to this abstract definition to say, well, look, an alloy is this mixture of metals, and we use alloys to make metals harder, give them different properties, and also in some cases to make them a bit cheaper as well. As I said in the previous video on the transition metals, there's going to be more on structure and properties and so on in the next unit, which in the GLT curriculum is probably going to be covered in year 10. So they're going to revisit these ideas in loads and loads of depth. So for now, that is the end of this unit. I hope these videos have been useful.